In this problem, we're given an exponential function f where the input variable x represents time. In fact, x equals 0 corresponds to the year 1998. So for example, x equals 1 would be 1999, x equals 2 would be the year 2000. You get the idea. The output of the function f of x, according to the story, is given to be the value of China's exports of automobiles and parts, and that's in billions of dollars. The question we are to answer is, in what year did, or in what year will, the exports reach $7.2 billion? So they're giving us the output variable is 7.2. Since the output is already in units of billions of dollars, it's sufficient to just replace f of x with the number 7.2, and that will represent $7.2 billion of exports. So where you see the output notation f of x, I'm going to simply replace it with 7.2 and then copy the rest of the equation. Now, since we're supposed to find out what year the exports reached $7.2 billion, that means we need to solve for x, which represents time. I'm going to solve this two different ways. First, I'm going to do it by hand and show you what the answer would look like without doing any rounding whatsoever. Then, I'll show you how to use the intersect feature on your calculator to get the same answer. Now, since the input variable is in the exponent position, we call this equation an exponential. In this class, you can follow what I call a four-step method to solve exponential equations. The first step is always to isolate the exponential term, and the order of these steps are important. You must do step 1 first. This, what I'm circling here, is the exponential term. It's always the base and the exponent that has the input variable in it. To isolate means to get it by itself, meaning this decimal here of 1.8208 needs to be taken to the side, and since that's being multiplied, I would do so by dividing both sides of the equation by it. So I'm simply dividing both sides of the equation by 1.8208 since it's being multiplied by the exponential expression. Because I want my answer as accurate as possible, I'm not going to use my calculator to the very end, which means I'm going to leave this fraction sit over here to the very end before I do the calculation on my calculator. So I copied the left-hand side. Now on the right-hand side, any number divided by itself is 1, and we usually don't write multiplication by 1, so we'll leave that out. So now we're on to step 2. Once you isolate the exponential term, it's time to take the natural log of both sides of the equation. This is very simple. You can always just write the notation for the natural log function. This is just the name of a function, just like the letter f is in the original function. Now once I've done this, it's simply a matter of copying the left-hand side of the equation in these parentheses and doing the same with the right-hand side. I'm literally copying the left-hand side and putting it in the parentheses. And now I'm literally making a copy of the right-hand side and putting it in the parentheses. That's all step 2 entails. I took the natural log of both sides of the equation. So now I'm on to step 3. Step 3 says if the base is e, which it is, this is a base e exponential. It started out as e from the beginning of the problem. To see what you'd do if the base wasn't e, refer to one of my other videos. But for this problem, the base is e, so this says if the base is e, use the property that the ln of e to stuff is always going to be able to be simplified down to be just the stuff. You can almost think of it as the ln and e cancel. What's really going on here is you have a base e exponential getting plugged into a base e logarithm. You've composed the two. Whenever you compose two inverse functions, they cancel each other out. Exponentials and logarithms are always inverses of each other, provided they're the same base. Ln is a logarithm of base e, and this is a base e exponential. So for my problem, the stuff in the exponent position is the 0.3387x. So that's all that will survive on the right-hand side. The ln of e to this circled expression would simplify down just to be what I've circled here. Once again, I'm literally making a copy of something and I'm just bringing it down. The ln and the e simplify out. I'm just left with the stuff. Now I'm going to copy the left-hand side of my equation. Notice I've never touched a calculator yet. I consider this an exact answer. Now that I've done step 3, I have one final step, which is a little vague, which just says to solve the equation for the input variable. The directions are a little vague because I'm assuming you know how to solve this equation for x, because there's nothing here except for a number being multiplied by x. Since the number is being multiplied by x, I'll solve for x by dividing both sides of the equation by that number. So I'm going to divide the left-hand side by, and the right-hand side by, 0.3387. So this simplifies down to be 1. So I'm left with 1x equals this monstrosity over here. So I'm going to write my answer, and I'm going to use an equal sign, not an approximate sign, because I've done no rounding so far. Move that up here, and this is what I'm going to call my exact answer. Now if you want an approximation of this answer, we need to type this into a calculator. After all, I have no idea if this represents 1999, the year 2000, or what, because I have no idea if this number is close to 0, 1, 2, 3, etc. So I've turned my calculator on. I press the natural log key, type in the 7.2 divided by 1.8208, close the left parenthesis here with the right parenthesis, and then all of that is being divided by 0.3387. This is where, even though I'm entering an exact answer into the calculator is going to give me just an approximation of this. The real answer has infinitely many digits. The fact that the calculator is only displaying 9 of those infinitely many means the calculator is rounding for me. So even though you as a student haven't rounded your answer, this is still a rounded answer. It is not an exact answer. But for the purposes of this problem, we need only get to the nearest year. So I'm going to say that this answer is approximately 4. So notice when I write that, to indicate to people that I have now rounded, I'm going to not use the equal sign. I'm going to say x is approximately 4. But we have to go back to the original problem and figure out what 4 means. X is basically the number of years since 1998. X equals 0 is 0 years since 1998. So if x were to be 1, that would be 1 year after 1998, which is 1999. So you get the idea that x equals 4 would be 4 years after 1998. So you simply add them, and if you did so, you'd get the year 2002, and that answers the question. In 2002, that's the year which China's exports of automobiles will reach $7.2 billion. Now that I've shown you how to do the problem by hand, I promised that I would also show you how to use the intersect feature of your calculator to get the same answer. So go to your graphing calculator, press y equals. I'm going to go back to the original equation. So this is what the equation looked like before I showed you how to solve it by hand using the 900-step method. I mean the 4-step method. To solve an equation using your graphing calculator, you always type the left-hand side into y1, which is just 7.2, and the right side into y2. So I'm going to press down or enter to get to the second equation. And by the way, the order in which you type these actually does not matter. You could type this in y1, and you could type the 7.2 into y2. Doesn't matter. To get to base e, one way to do that is hit second and then the division key. Then I'm going to press the caret key here to tell the calculator the rest of the problem is in the exponent. Now because my calculator is in classic mode, if I was just to type the 0.3387x without parentheses, it turns out that the x would not be in the exponent position. The calculator assumes when I use a caret key with no parentheses that only the first thing written is in the exponent and not anything else. So I'm going to have to put a right parenthesis here, and I'm going to back up and insert a left parenthesis right here. To insert something, you press second and then the delete key. That changes my cursor to a flat line that tells me I'm in insert mode, and I will press left parenthesis. I think we're going to get lucky here in that our answer shows up in what's called the standard window. The standard window shows from -10 to 10 on the x and y axes. I know that y equals 7.2 is a horizontal line through 7.2, which is a number between -10 and 10. So at least at first, if I was to press zoom, and then option 6 is standard, so I press 6, I will at least see the horizontal line y equals 7.2. But I think we're getting lucky because my exponential here starts at a value of 1.8, which is also in the window from -10 to 10. In fact, this is about 1.8. And it grows fast enough that the answer to my problem turns out to be a number between -10 and 10, meaning China's exports will reach $7.2 billion in the first 10 years since 1998. Now I need only find the x value of that intersection. I'm going to press second, the calc menu. I'm going to select number 5 for intersect. It's asking me if this is the first curve, y equals 7.2. I press enter for yes. It jumps down to the second curve, this equation. Yes, that's the second curve. I press enter. It's asking me to guess. It wants me to trace over to where I guess that they intersect. But it turns out you can be a bad guesser and just press enter. And since there's only one intersection on my screen, it'll find the one I want. So we get the same answer before of x being approximately 4 units. Approximately 4 units since 1998, exports are exactly $7.2 billion.